This is 4-5, all about completing the square. All right, so for this warm-up, let's take a look at solving an equation using the square root property, which we've been working with now for a couple of sections, okay? So this idea, if I have a quantity, x minus 3, that's being squared, and that's equal to 16, I could just take the square root of both sides, right? And then that's going to free up on the left side from the exponent. Right? Keep in mind, because we are the ones introducing that square root into the equation, we have to put a plus or minus sign. You may also notice that the square root of 16 is 4, so we can take it one step further and go x minus 3 equals plus or minus 4. Excuse me, sorry, my brain is moving faster than my mouth, okay? Meaning that if we add 3 to both sides here, this is what we'll work with, okay? X equals 3 plus or minus 4. So we have two solutions, right? We have 3 plus 4, or we have 3 minus 4. So x could equal 7. X could also equal -1. Okay, that's what this plus or minus symbol means. So quadratics, we're working with two real solutions for this parabola. So that's going to lead into, like, this format is going to lead into this next question, right? So picture if I took this warm up, and let me erase my square roots up here just so we can track, right? Imagine if I multiplied this out, x minus 3 times itself. Then we're looking at this, right? Except we would have a minus 6x in the middle, but the concept, still works, okay? So let's solve this by factoring. And I know that with factoring, I have, drilled it into your brains that you have to make sure we're equal to 0. But let's try it without doing that, right? Let's see what happens. So let's take this left side, and we can factor it into x plus 3 times itself. Okay, and we're equal to 25 still. Notice that we can rewrite the left side as x plus 3 squared, and we're still equal to 25. Now, what can we do? We can just take the square root of both sides like we did in the warm-up, right? X plus 3 equals, because we are the ones introducing the square root into the problem, we have to put a plus or minus sign. And then square root of 25 is 5. Okay, so then x equals -3 plus or minus 5, meaning that x could equal 2, or x could equal -8, right? So there's other ways to work with this, right? This works because we have a perfect square trinomial on the left side, okay? So this means that the trinomial factored into two identical binomials, allowing us to then use the square root to solve, right? So we see this factored into x plus 3x times itself, and then we could just take the square root, okay? So we can actually force this to happen every time if we want with a quadratic. So this is called completing the square. Let's see what this means visually. So on the left side, we have x squared plus 6x equals 16. So we do not have a perfect square trinomial on the left. We're missing that third element, right? We're missing the third term. So there's a really cool GeoGebra animation that can work with this, right? So this is what we have, x squared plus 6x equals 16. And so watch this, right? Watch what's going to happen as I drag this slider. It's going to walk us through a certain process. So we're going to take our x squared and our 6x, and we're going to draw some diagrams. Okay, so we can take this x squared and we can recreate it visually as a square with side length x and x. Okay, we can recreate the 6x term as a rectangle with side lengths 6 and x, right? And then so their areas are going to be represented by x squared and 6x, okay? So let's try to make this whole thing into a square, right? So let's try to split this rectangle in half and try to make this entire thing into a square. So we're splitting into two identical rectangles. That's where we're getting the idea that we can write it as two identical binomials, right? And then this right identical triangle is going to come down and around. We're going to close some gaps here. And now what are we looking at? We're looking at an incomplete square, right? So we have a new square with side lengths x plus 3 and x plus 3, right? So that's where we're rewriting it as see, it's where we're rewriting it as x plus 3 times itself, okay? And it has to equal the same area, so we have to fill in this square. If we want to be able to multiply those two binomials together, we have to fill in this little square down here. And the amount that we need to fill in the square is with another square, right? With side length 3 by 3. So what we can do is add 3 squared to both sides, and then use this idea to solve with a square root. Okay, so that's a visual representation. Here's what this will look like algebraically. Okay. Well, what's the GeoGebra animation doing? Draw a picture or explain words. You could write something like it's completing a square by adding units to both sides. Okay. So here's our process algebraically. Okay, we're going to move C to the other side away from the variables. If A is not 1, so keep in mind when we talk A, B, and C, we're talking ax squared plus bx plus c equals 0, right? So we're going to move C, we're going to move whatever that constant is over to the other side so that we're just left with ax squared plus bx so that we have something to complete. Right? If A is not 1, then we have to divide everything by A. We have to make sure that leading coefficient is 1 in order for this to work. Then we're going to take half the coefficient of x, square it, add it to both sides, factor our perfect square trinomial, and use the square root to solve the equation. All right, so practically, here we go. All right, let me go back and finish this out. Okay, practically, here we go. X squared plus 6x equals 16. We already have our constant moved over. Okay, so what we're going to do is we're going to add something to both sides. And what we're going to add to both sides is that middle term, 6, half of it squared. Right, so half of 6 is 3. So we're going to add 9 to both sides. All right, and so this left side can factor now into x plus 3 squared, which is equal to 25, meaning that x plus 3 equals plus or minus 5 if you take the square root of both. X equals negative 3 plus or minus 5, meaning that x equals, guess what, 2 or negative 8, which is what we just worked with. Okay, so let's try this example together. First thing we got to do is move C to the other side. X squared plus 5x. I'm going to leave a little bit of space, add 1 to both sides. And then now we have to complete the square. We got to add something to both sides, right? So we're going to add half of our middle number, 5, half of our middle coefficient, and then square it. I'm always going to write this out because, fun fact, when you get down to rewrite it as a binomial squared, this is the element that, or this is the constant that you're going to be adding or subtracting inside those parentheses, okay? So this turns into, let's see, 25 over 4. So we're going to add that to both sides. We have to add it to both sides because we have an equation. We can't just start changing the value of things all as we want to, right? We got to keep it somewhat equal. We have to keep it equal, okay? So now this left side is going to factor into x plus 5 halves, right? Whatever I'm squaring is what this is going to factor into. And that's equal to 1 plus 25 over 4, which as a fraction should give us 29 over 4. Now let's take the square root of both sides. Because we are introducing the square root, we have to put a plus or minus sign. And that square root, that radical is extending over the numerator and the denominator, okay? And then let's try to get our x by itself and simplify as much as we can along the way. X equals negative 5 halves. I'm going to subtract from both sides. Plus or minus square root of 29 over 4. I'm going to simplify that as a square root of 29 over 2 because I can take the square root of 29 over the square root of 4 to simplify this, which will give me the square root of 29 over 2. All right, and so if I really wanted to, I could leave it like this, or I could, since I have a couple of 2's, I could rewrite this over one denominator, right? Negative 5 plus or minus the square root of 29 all over 2. And you can just leave it like that. What's great about completing the square is it works every time, right? Factoring to solve quadratics only works when you have 2 real solutions, but completing the square will work every single time, no matter what. Okay. You try this. Pause the video. Alright, so we're going to go through this one, and then I'm going to end this video and start another one. Let's rewrite as x squared minus 10x, leave a space, it's equal to 8. We're going to take half of that middle term b, square it, add it to both sides. So 25 is what we're going to add to both sides. My left side is going to factor into whatever I'm squaring, right? As a perfect square trinomial, I can rewrite this, which is equal to 33. Take the square root of both sides. X minus 5 equals, because I'm the one introducing the square root, we have to put a plus or minus, meaning that x is equal to 5 plus or minus the square root of 33. Okay, we're going to pick up next with what happens when our leading coefficient is not 1.